Hello everyone, welcome back to Physics online classes for class 12 students. Let us continue chapter 3 current electricity. Today we are going to solve NCERT numerical problems part 3 as we have completed up to 3.10 numerical problems in the previous class. So today let us continue the remaining NCERT numerical problems. Yes, so we can solve the 11th problem 3.11. A storage battery of EMF 8 volt and internal resistance 0.5 ohm is being charged by a 120 volt DC supply using a series resistor of 15.5 ohm. What is the terminal voltage of the battery during charging? What is the purpose of having a series resistor in the charging circuit? See here, a storage battery which is having EMF 8 volt and also it is having internal resistance 0.5 ohm is being charged by 120 volt DC supply using a series resistor of 15.5 ohm. When we are using a storage battery which is going to charge with the help of a DC supply which is having EMF 120 volt. So now we can consider the net EMF in the circuit will be. See here, when the storage battery of 8 volt is charged with a DC supply of 120 volt, now we can consider the net EMF in the circuit. Is how to find net EMF in the circuit? Let us take the net EMF as E dash is equal to. A storage battery is going to be charged with the help of DC supply, that is 120 volt minus storage battery is how much? 8 volt. So 120 minus 8, that gives net EMF in the circuit. 120 minus 8 is how much? 112 volt. This is the net EMF in the circuit. E dash equal to 112 volt. What is the terminal voltage of the battery during charging? So before going to find the terminal voltage, first we have to know how much current is present in the circuit during charging. So now let us find current in the circuit during charging. Current in the circuit during charging means we can use the equation I equal to E divided by R plus R. We already know this equation. Here instead of E, I can take a net EMF E dash divided by R plus R. Let us substitute the values. Here you can observe the givens. Internal resistance is denoted by R. R is given 0.5 ohm. Using a series resistor, external resistor capital R is given 15.5 ohm. Substitute here 112 divided by R plus R, that is 15.5 plus 0.5. So we will get current in the circuit will be 7 ampere. Yes. So how much current is there in the circuit during charging? 7 ampere of current is present during charging. Now we can find terminal voltage of the battery during charging. Yes, what is the formula for terminal voltage? See here, the terminal voltage of the battery, during charging. Yes, we know the equation V equal to E plus IR. Substitute the value V equal to E is how much? That is, remember E indicates EMF of the battery. That is E equal to 8 volt. We want a net EMF, that is E dash equal to, we got 112 volt. 120 volt is what? This is one DC supply. Using that 120 volt external DC supply, we are charging the storage battery. So in place of E, we have to write 8 volt plus IR. I value we got 7 ampere. Internal resistance is how much? 0.5 ohm. So 8 plus 7 into 0.5. We will get terminal voltage as 11.5 volt. Yes, this is the terminal voltage. Then one more question is there here. What is the purpose of having a series resistor in the charging circuit? So why we have to use resistors in series? What is the use of series resistors in this circuit? Remember, the series resistor limits the current which is drawn from the external source. To limit the current or to control the electric current, we have to use a series combination of resistor, because we know that series combination means we can use the equation Rs equal to R1 plus R2 plus R3 so on up to Rn. So when we are using series combination, the value of resistance increases. We are going to add, or the sum of all the resistor value that gives series combination. So here the value of resistance increases, so that current decreases. So why we have to use a series resistor in this circuit? Only the answer is the series resistor limits the current which is drawn from the external source. So if you are not using any series resistor combination, then remember the current will be dangerously high when the series combination of resistor is absent. When you are not going to use this combination, in its absence, the current is dangerously high. So to limit the current, we have to use series combination of resistor. Yes, what is the answer? See here, the series resistor limits the current drawn from the external source. If you are not using series resistor combination, then remember the current is dangerously high. Is it clear? Yes, now we can go to the next problem, 3.12. In a potentiometer arrangement, a cell of EMF 1.25 volt gives a balancing point at 35.0 centimeter length of the wire. If the cell is replaced by another cell and the balance point shifts to 63.0 centimeter, what is the EMF of the second cell? Yes, we already studied about potentiometer in our theory classes. You can remember the direct equation we are using. E1 over E2 is equal to L1 over L2. Here, potential difference or EMF is directly proportional to balancing length. E1 over E2 equal to L1 over L2. See here, first we can write down the givens. In a potentiometer arrangement, the first cell is having EMF 1.25 volt. Let us take it as E1 is 1.25 volt. It gives a balancing point. Let us take it as balancing length L1 is given 35.0 centimeter. If that cell is replaced by another cell, we can take it as E2, and we don't know the value of E2 question mark. But we got balancing length L2 equal to 63.0 centimeter. What is the EMF of the second cell? Means we have to calculate E2. Or we can write it as E2 equal to, we will get L2 divided by L1 into E1. Right? E2 equal to, what is the value of L2? 63 centimeter into E1, EMF of the first cell is 1.25 divided by length for the first cell is 35 centimeter. So calculate these value, we will get EMF of the second cell as 2.25 volt. So this is EMF of the second cell. 13th problem, 3.13. The number density of free electrons in a copper conductor estimated in example 3.1 is 8.5 into 10 raised to 28 per meter cube. So you can remember the first example, first numerical problem. According to that example, we can estimate the number density of free electrons in a copper is how much? 8.5 into 10 raised to 28 meter cube per meter cube. How long does an electron take to drift from one end of a wire 3 meter long to its other end? The area of cross section of the wire is given 2 into 10 raised to minus 6 meter square and it is carrying a current of 3 ampere. So first we can write down the givens. The number density of the free electrons in a copper conductor is given. Let us take number density of free electron N is given. That is 8.5 into 10 raised to 28 per meter cube. How long does an electron take to drift from one end of the wire to other end? How long does that means how much time that electron can take to move from or to drift from one end of the wire to another end means we have to calculate time. Then here the length of the wire is given. Let us take it as L equal to 3.0 meter or 3 meter. Then area of the cross sectional of the wire is given A equal to 2.0 into 10 raised to minus 6 meter square. And it is carrying a current I equal to 3 ampere. These are the givens. So what we have to calculate? Time interval. How much time an electron can take to drift from one end of the wire to another end. See here, first I am going to use the equation for drift velocity. To find drift velocity is denoted by Vd. To find Vd, we have the equation I equal to NAE into Vd. But we want drift velocity, Vd equal to the equation can be written as I divided by NAE. Substitute the values. I value is given 3 ampere divided by N value is given 8.5 into 10 raised to 28 into area of cross section 2 into 10 raised to minus 6 into E value is how much? Charge of the electron 1.6 into 10 raised to minus 19. Substitute all the values. So after calculating we will get the final answer 0.1102 into 10 raised to minus 3 meter per second because this is a velocity, drift velocity. Yes, how much we got? 0.1102 into 10 raised to minus 3 meter per second. But what we want? Time. So we know that velocity is generally given by the equation displacement divided by time. So therefore I can write drift velocity Vd. Velocity is equal to displacement over time interval that gives velocity. The rate of change of displacement that gives velocity. So instead of displacement I can write the length of the wire L over time T. But we want time. So T equal to the equation becomes L divided by Vd. Length of the wire is given 3 meter divided by drift velocity we got 0.1102 into 10 raised to minus 3. So we will get the time interval T equal to 27.2 into 10 raised to 3 seconds. So here 27.2 into 10 raised to 3 second time is taken by an electron to drift from one end of the wire to another end. Yes, 14th problem. The Earth's surface has a negative surface charge density of 10 raised to minus 9 coulomb meter square. What it is? The surface charge density on the Earth's surface. Then the potential difference of 400 kilovolt between the top of the atmosphere and the surface results in a current of only 1800 ampere due to low conductivity of lower temperature. So we have the current 1800 ampere. This is over the entire globe. If there were no mechanism of sustaining atmospheric electric field, how much time would be required to neutralize the Earth's surface? So this never happens in practice because there is a mechanism to replenish electric charges, namely continual thunderstorms and lightning in different parts of the globe. A radius of the Earth is given. Yes, see here, according to this numerical problem, we have to find how much time would be required to neutralize the Earth's surface. We have to find time interval. So first we can note down the givens here. Surface charge density of the Earth is given. Surface charge density Surface charge density of the earth. Surface charge density is generally denoted by the symbol sigma. It is given 10 raised to minus 9 coulomb meter square. Then current over the entire globe is given. Current over the entire globe. It is given I equal to how much? 1800 ampere. Then a radius is also given, a radius of the earth. Let us take it as R equal to 6.37 into 10 raised to 6 meter. This is radius of the earth. Easily we can find the area of the or the surface area of the earth. So now we can find surface area of earth. Yes, surface area of earth means we can write A equal to 4 pi r square. Substitute the value 4 into 3.142 into radius is given 6.37 into 10 raised to 6 whole square. So we will get the final answer, that is 5.09 into 10 raised to 14 meter square. This is surface area of the earth. Now we can find time taken, how much time is taken to neutralize the earth surface. So we have the equation for current I equal to Q by T. T equal to, we can write here, I equal to Q divided by T. So we want T value. So T equal to, the equation becomes Q divided by I. So this equation we can use to find the time interval. I value is already given 1800 ampere, but we don't know the value of Q. So first we have to find the value of Q, then we can easily find time interval. Yes, we know that charge on the earth surface. So here I am going to write here. Charge on earth surface. Charge means it is denoted by Q. On the earth surface means we can take surface charge density of the earth sigma into its surface area. That gives a charge present on the earth surface. So we will get Q value as sigma is given 10 raised to minus 9 into area, surface area of the earth we calculated, and we got 5.09 into 10 raised to 14 meter square. So now we got Q value. So we will get 5.09 into 10 raised to minus 19 plus 14 will be 5 coulomb. So now we got charge on the earth surface. So therefore time taken to neutralize the earth's surface. Let us take it as a T equal to, what is the equation? See here, first we can use the equation I equal to Q divided by T equal to Q divided by I. Substitute the value. Q is 5.09 into 10 raised to 5 divided by the current over the entire globe is 1800 ampere. Calculate this value, we will get nearly, the answer is 283 seconds. So it requires 283 seconds to neutralize the earth surface. Yes, 15th problem. In that first A question, 6 lead acid type of secondary cells, each of EMF 2 volt and internal resistance 0.015 ohm are joined in series to provide a supply to a resistance of 8.5 ohm. What are the current drawn from the supply and its terminal voltage? We have to find electric current and terminal voltage. That is the first question. Yes. So 6 lead acid type of secondary cells and each is having EMF 2 volt. So first we can write, this is question A. I am going to write total resistance in the circuit. Total resistance in the circuit, which is taken as R equal to, see here, total resistance we have to write. How many lead acid type of secondary cells are present? 6. And these each secondary cells are having EMF 2 volt. And these are having internal resistance 0.015 ohm. 0.015 ohm is internal resistance of each lead acid type of secondary cell. So we can write 6 into 0.015. This is internal resistance for each cell, plus one more external resistor is present and it is having the value 8.5 ohm. So we will get a total resistance in the circuit is 8.59 ohm. Right. Now we can find current drawn from the supply and also terminal voltage. So current in the circuit. Current in the circuit, we can write the equation I equal to here E divided by R. We can use the Ohm's law equation I equal to V by R. So V means what here? EMF or the potential difference. So EMF of the battery it is given I equal to E divided by R. Here you can observe there are totally 6 secondary cells. Each cell is having EMF 2 volt. So 6 into 2 divided by total resistance present is 8.59. 12 divided by 8.59, that gives the value 1.39, or we can write 1.4 ampere. This is current in the circuit. Now we can easily calculate a terminal voltage. So terminal voltage is denoted by V. V equal to, we can use the equation I into R. V equal to IR. I value is 1.4 into resistance is 8.59. So we will get the final answer 11.9 volt. So this is terminal voltage. Then come to the second sub question B. Here a secondary cell after long use has an EMF of 1.9 volt and a large internal resistance of 380 ohm. When we started to use a secondary cell for longer time, so its EMF reduces to 1.9 volt and its internal resistance increases to 380 ohm. What maximum current can be drawn from the cell? Could the cell drive the starting motor of a car? First we have to find maximum current drawn from the cell. See here, EMF of the battery is given 1.9 volt. Internal resistance is given 380 ohm. So we want current. So we know that I equal to E divided by R because there is no external resistor capital R. So I equal to E by R. E value is 1.9 divided by R value is given 380. So we will get the answer 0.005 ampere. So only this much amount of current we can draw from the cell, 0.005 ampere. The question is, could that cell drive the starting motor of a car? It is impossible. It is impossible to start a motor because a starter motor or starting motor of a car, it requires large current for few seconds. When you are going to start the motor, you need large amount of current. So nearly we required 100 ampere of current. So we got 0.005 ampere. This is very small amount of current. So from this amount of current, it is not possible to drive the starting motor of a car. So the answer is, could the cell drive the starting motor of a car? No, it is impossible to drive the starting motor of a car because it requires large amount of current. It requires nearly 100 ampere. But we got 0.005 ampere. This is very small amount of current. From this amount of current, it is not possible to drive the starting motor of a car.